Hi all. Let's start with the graphs today, the trigonometric graphs. Now, this is fairly misunderstood and thought, and a lot of children I've interacted with find it difficult to draw the graph. It's extremely simpler, I mean, more simpler than the Cartesian normal graphs that you draw in your geometry. So I'll just take an example. For example, someone says you have to draw a graph y is equal to sine x, sine theta, sine z, whatever. This is the angle, right? And just imagine that there is one here. And then there's a graph which is y is equal to 3 sine x. First of all, I want you to note down the difference between the two. This y is simply 3 times this one, right? X is same. So this from this, I would reduce the period of the graph. The period of the graph, period of anything is where it starts repeating itself. So period of this graph is 2 pi or 360 degree. The period of this graph again is 2 pi, 360 degree. And this I would call amplitude. You would, I'm sure, whoever would have studied the oscillation must remember this, right? So the amplitude here is 1 and amplitude here is 3. Now, drawing that graph is absolutely simple. How is it simple? Let's take few points in terms of this angle. If x is equal to 0, y is equal to 0 because sine 0 is equal to 0, right? If x is 90, I'm talking about the first one, then y obviously is 1 because sine 90 is 1. Anyways, I'm sure you would recall that the graph will lie between these two numbers. So it can't be greater than 1 and it can't be less than -1. Pick up some more points, which is 270, right? You could take it as 270, you will get -1, you can take 360, and you will get 1. So if you see the some points, this is a point, this is a point, this is a point, this is a point, this is a point I'm talking about. A lot of children will have question that since you've taken point, why don't we have a straight line like this? Because the value from 0 to 90, if you remember, sine 0 is 0, 30 is half, right? Then 45 is 1. Then 60 is root 3 by 2. The values are not linear. So since the values are not linear, the graph will not be linear. The graph will be like this. If you understand this particular logic, you can draw any graph that you want to. I have used similar logic in drawing a graph which is y is equal to 3 times of sine x. Nothing has changed. No change in period. The only thing which has changed is the amplitude. The graph is simply 3 times stronger or 3 times bigger, this wave. So, for example, now if x is equal to 90, y is not 1, y is equal to 3. Again, the takeaways, key points you can see, these graphs are extremely helpful in the inverse trigonometric function. In fact, there's a lot that you can do without doing anything if you know how to read a graph of the trigonometric function. Now let's come to the second function, which is again the same story. I mean, okay, it is sine x. The second function is y is equal to cos x. How do I draw the graph of y is equal to cos x? I'm going to use my pen, and this the obviously the tablet will not. I'm not great at drawing, but I still will try. In here, if you take x is equal to 0, y will be 1 and not 0. So if I draw axis, on this axis I have my amplitude, and on this axis I'll have angles, right? So 0 means 1, so the graph will start from here. And if I take x is equal to 90, y will be equal to 0. So the graph will be crossing this. So the graph will go down like this. All right. Okay. It crosses the axis, and you know that these graphs always work like this. And the point of repetition will be this one. So uh, this will be 180 because 180 is minus 1. This will be 270, right? 19, 270 is 0. This will be 360. And this would go on and on and on. There is no difference between the two. In fact, uh, last lecture I said that there's a transformation that we can have. I can have a cos graph from a sine graph simply from you can take any point is your origin. It doesn't matter. You consider it as zero. Correct. So this will be a graph of the cosine function. You can draw cos 3x, cos 5x, 6 cos x, 7 cos x. It doesn't matter. There is a little comparison that I've shown, which is the way that I do graphs. So this is sine x and sine 3x. My point is simple. Let's not even get into the numbers as such, that it has a period, let's say, of uh, this is very, very qualitatively, not quantitative. This is the entire sine graph, and there's repetition. So it has how many segments? One, two, three, and four. What's happening is when I'm saying 3x, how many segments do you think it should have? So what first I will do is that I would divide it into three equal parts. You see it happening here? That this is y is equal to sine x, this is pi, this is 2 pi. And this is divided into 1, 2, 3 equal segments. Number 2, the period is 360. In here, the period is 360 divided by 3, which is 120. So the graph should repeat after 120. So this particular point will be 120, and this particular point would be half of that. So if this, let's say this is 4x. So this particular thing, this particular thing, this entire thing, this one will be divided into four equal halves. We call it frequency will increase. I mean, in this space, if there was half a cycle, right? And in this space, if there was one cycle, and this is saying 5x, there will be 5 cycles. I'm sure you can. Again, once you start getting into it, it'll be very, very easy for you just by looking at the frequency and the time period and the amplitude, how to draw it. The different graph that we have here is equal to, which is y is equal to tangent or 10x. This is a little weird. Uh, this is not like these, and this is the repetition is not the way you think. There are breaks in it, and if you would have studied, in basic differentiation, you remember continuity, right? So there's no continuity here. Why? I can write it as sine x upon cos x. And let's say that I take x is equal to 0. So I get 0 by 1, which is fair enough. That's great. If I take x as 90 degree, what happens then? This becomes 1, this becomes 0, and this is not equal to infinity. Uh, we call it infinity. I mean, that's up to you. But this is undefined. So what we are saying is that currently the rules of mathematics that we have discovered, not invented, we don't know what to do with this, right? So if you see the graph here, let's say this is 0. Okay, this is the positive side, this is the negative side. 0, 0 is 0. But what I'm saying is that I'm drawing a line right? This line is called asymptote. Doesn't matter what it calls, it hardly matters. So what we are saying is that we are not going to 90, but we are close to 90. The closer you get to 90, the higher value it becomes. So, for example, if the number is smaller, suppose this number is not 0, this number is 0 point this, and then number gets more smaller, 0.001, right? So this number will be obviously much greater than this number. As this number approaches 0, this line approaches, I don't know where, I still won't call it infinity, but it is not defined here, right? So at pi by 2, there is a break, right? Now you come to pi, which is sine 180 by cos 180, which is again 0, right? Again, the same story. At 270, it's not defined. So graph will go like this. And then graph will have negative values between pi by 2 and pi, for the simple reason that one of the ratios, sine and cos, will assume negative values. So this is how you draw the graph of 10x. It's an exercise to you to draw graphs of, again, these are very simple: cosec, since you know sine; sec, since you know cos; and cot, since you know 10. This is something where you'll have to do a bit of a thinking. Otherwise, extremely, extremely simple. And remember, we will use these in the coming chapter. So let's look at some of the examples for the trigonometric graphs. Most of these questions are pretty similar if you know how to get the maximum and minimum value. Now, for example, it says y is equal to cos x pi minus 4. Can you see, if I have x is equal to pi by 4, I will have cos 0. That means y will be equal to 1. So the graph attains its maximum value not at x is equal to 0, but x is equal to pi by 4. So you can very well understand that the graph will be shifted by pi by 4 to the right. Correct? Again, at pi, the value had to be minus 1, but this interval is pi by 4. So it will be 5 pi by 4 this side. So this was easy. Let's come to next question and see. We need to sketch this graph. 3 sine, so the function is 3 sine 2x minus pi by 2 and minus 2, and the function is fx or y, whatever. Let's check what is the maximum value that this guy can have. Obviously, the maximum value of sine is 1, and it would be at pi by 2. When the value is 1, this will become 3 minus 2 is equal to 1, where 2x minus pi by 2, if, sorry, if this is pi by 2, I'm going to get, this guy gets here, becomes pi, and x is equal to pi by 2. So at x is equal to pi by 2, the graph will attain its maximum value. You can see here, this point is pi by 2. How about the minimum value? We just check two values. How about the minimum values? So this guy has to be minus 1. In case it is minus 1, the value will be minus 3 minus 2, which would be minus 5. And this is minus 1 at 270, right? So 270 means 90 into 3. So 3 pi by 2, correct? Should be equal to 2x minus pi by 2. So I can take this here. This will be pi by 2, right? And I will have, no, this will be 4 pi by 2, 2, 2. So the answer will be, at x is equal to pi, the graph will have a negative value of minus 5, which you can see here. Now, I want to see what happens when x is equal to 0. Now, when x is equal to 0, I get 3 sine minus pi by 2 and 3. And sine minus theta, it's an odd function everybody knows by now, it's minus sine theta. So I'm going to get minus 3 and minus 2, which would be minus 5. So these are the major points that you can see. Try and see at x is equal to 0, try and see where is the maximum value, try and see where is the minimum value. Let's look at one more, which is 3 sine x by 2 minus 2. X is, by the way, angle here, right? Between 0 to 4 pi. So let's see. Let's see what is the maximum value here. The maximum value can be 1. When the maximum value 1, y will look like 3 minus 2 is equal to 1. And where will it be? X is equal to, x by 2 should be equal to pi by 2. Right? So x is equal to pi, y will be 1. I think you can see it here. Okay, let's see the minimum value. And what happens? Minimum value of this guy could be minus 1. Again at 3 pi by 2. So when this is minus 1, this goes to minus 5. So minus 3 minus 2 is equal to minus 5, and x by 2 should be equal to 270, which is what? 3 pi by 2. So at 3 pi, this will be minus 5. What happens when I have x is equal to 0? So I will have 0, 3 sine 0 minus 2. So I'm going to have minus 2. So this is where the graph is. Again, these are simply very simple graphs. I would encourage you to do a lot more questions on these, and in every question just remember what you need to do. Just check at x is equal to 0, just check at the maximum value, and just check at the minimum value. I hope it was